Okay, today I want to make a geometry which is called a hyperbolic coral. It's a nature coral, but has the element of hyperbolic surface. Looking like this. Yeah, this kind of shapes. And in order to make those shapes, there is a method called differential growth. And a design studio called Nervous System did a simulation for this before, maybe using open frameworks or something, and and it shows how you can achieve this kind of shape. And looking at these, they say you need to have like a disk first and select the area that you want to extend or expand the mesh edges, like the green area on the image, and then each frame like recursively expand those edges time by time, frame by frame, and then remesh after you expand the line to have a constant edge length. When you do that, you have this kind of wavy shapes on the edge when the edge is on when the disk of the edge can only be expanded. It happens like these. If you do it continuously, do the same process again and again, you'll have something really similar to the hyperbolic coral, like these. So I want to have something like these in Houdini, and let's do that. So first I want to make a circle to start off, and for this time I'm just gonna make a low resolution hyperbolic surface, meaning not many like waves. Oops. First I'm gonna make a geometry and make a circle as a base. And let's make the radius like 0.2 by 0.2. Since it's gonna expand, to start off small I think it's okay. And make this polygon. And right now it's a bit too pointy, so I'm gonna make the division like 200, 128 or something. Yeah. And after that, I'm gonna resample this circle with specific lengths. And right now it's 0.1, so that could be okay for now. I'm just gonna leave it like this. And in order to make like a wavy pattern, I wanna make an initial condition of these points, like how they wanna move, how they wanna expand. Like if you, for now it's on the flat plane in XY plane. So if I try to expand those edges, it's just gonna go expand to the XY plane and then might not go to the 3 dimension, so like in Z axis. So I want to offset each points a little bit to the Z direction, maybe using like a sine function. to make it more wavy as initial condition, so that it will easily go to 3D. Now I can use the point wrangle for that. Let's say it's edge wave something. And for here, I just want to move the point. Maybe I just want to move the point Z to maybe 0.05 times sine pi times 2, which means 360 degrees, times how many waves do you want? Let's say it's 4, divided by number of points you have, times the number of point, the index of point. Now it doesn't give me any changes. Let's see if I have any result from this. Let's insert it into value and show a geometry spreadsheet and assign this value to some random variable, and I do see a number here, but it's too small. I can see it's too small. So let's make it a little bit bigger. I see. I have to make this multiply. And let's see. Yeah, looks okay to me for this. Then finally use that value to update the Z position of the point. Yeah, that should be okay. It's pretty low res, but it's okay. It's gonna be remeshed later, so. And from here, let's add a null to be a controller which have all the parameters you can control. Okay. Now, after I moved the edges to Z direction like in a sine wave, using a sine wave, let's have a remesh function, remesh node to be attached. This will give a feed geometry to have the specific lengths and be subdivided within specific lengths. So right now it's 0.2, but then I want to make the same length as the edge length, which is, I set it to 0.1, so I'm gonna set it to 0.1 as well. And looks okay, but I can increase the iterations to make it more this to make it at same length as much as possible. Yeah, so Tang might be okay. So, and I can also add a new parameter here called as remesh iteration to control how many iterations you wanna, how many times you wanna calculate the remesh. Ranges could be from 1 to 10. And let's say it's 10 as a default, and copy this parameter and paste it inside here to the iterations variable in remesh. Now this is the initial state of the coral. Now what I want to do next is to first add some attributes to each point. Or maybe I don't have to. Yeah, maybe just skip the attribute part. There is a really handy node in Houdini that you can expand those lines, expand the lengths of the edges that connect that point that connects each points, which is called point relax. And I can just directly use that. And since we want to move it in 3D, which I'll just check this relax in 3D, and point radius attributes. Then I might need to have the p scale attributes on each point. So let's just create a attribute create, and let's name this p scale and default to be, well, since this is gonna be a point radius, which means how it's gonna scale up is to look at each points, and each point have this radius, like, which affects the relaxation, which means expansion. And if the radius for 2 points together are the addition of 2 radiuses of each point are bigger than the current edge lengths, then it's gonna expand to match with the addition of 2 radius, which is the point radius of each point. So for example, if this length is 0.9 and each point radius has like 0.05, which means that the addition of those 2 radiuses will be 0.1, then this 0.9 length of edge wants to be expanded like into this direction to be a 0.1 length. And I can see that not all the edges are exactly 0.1 right now. Some could be like less than 0.1, some could be more than 0.1. If it's more than 0.1, it's not going to be relaxed. Maybe it's going to shrink instead. But I think there are a lot of edges that's less than 0.1, so this might just work if I just say that the p scale of each point is half the size of the one I set here, the 0.1, the length of 0.1 that I used in remesh and resample. Now since we are gonna use this 0.1 that's set in this parameter a lot, I can just make another parameter for that. Let's say fit length. And I can just say from 0 to 1 and make it as a float. And let's set it 0.1 and copy this parameter and paste it here, paste relative reference, and also here. Yeah. And for our attribute creates, I want to set the p scale to be 0.1 divided by 2, which gives 0.05. And this says same for days, 0.1 divided by 2. Yep. And now, now that I have this, I can input these points with p-scale attributes into relax. And I can see I already see some changes here. It's trying to relax to make it like 0.1 lengths between points and points, between points, 2 points. But right now it's a bit too much of a movement for this kind of resolution. And this is done mostly here, max iterations. If I decrease these numbers, the gestures will be less. So 1 is enough. Maybe 1, even 1 is a bit too much. For this, looks okay, but if for calculating the growth of the coral, you need to recursively call this in solver, so even 1 is too much. So I'm gonna add one more a function to make it a little bit slower. In order to do that, I'm gonna add a point wrangle for this and set the points from attribute creates to the first node, first input, and then the relax one to the second input, and compare those 2 points to make it slower. So I have the first position, let's say vector pt1 equals the base position of the point comes from the attribute create. And I also have this pt2, which is a point position of the relax one. This one. So I have this point and this point. And since we have these 2 points that's as moved and before moved, we can see the difference. We can get the difference of these 2 points for each point, and then I can just set how much they should move to the goal position. Like you can set the already relaxed one to be the gold, but you can just say move like 10% from the original source to the target. Then it will be much less significant when they move, how much they move. So maybe I should have another parameter to control how much they should move from source to the target. So let's have another parameter here to the controller. Let's say it's integer. name it slow factor, and ranges from 1 to 10 around. So more number, more slower. So let's say it's around 5 right now. So which means I want to move this 20% from source to target. So in order to use that, let's first copy this parameter and go back to the point wrangle and say the new point is from PT1 to get the position, get the vector, moving vector from PT1 to PT2 divided by the parameter we just have made. And let's make it CHF. Could be CHI as well, but so this is supposed to move just 20%. So let's see. This is the original. And this is the target. And I can see it's just, and this is the final one. And I can see it's just moving, it's 20% from source to the target here. Yeah, this is good enough. And finally, I want to remesh this again. To the same edge length, 0.1. So more and more expand, the more the edges expand. You need more, you'll be having more number of edges with 0.1 lengths. That is the point, to make the coral grow. So let's copy the parameter here again and paste it in here, the target edge length. And also let's have the same remesh iterations used in the iterations for the remesh. Now this one have 30 points, this one has 28 points, so already it increased like 2 points. It's a bit slow, but it's pretty okay. More and more you go forward, it's gonna be much faster. Now this is just one update for one frame, and you need to do the same things over and over again in order to make it grow. So I wanna make a solver to have these functions run again and again and again. So let's have a solver here and cut this function and paste it here and connect it here. This be the last node, and let's see how it goes. Nope, nothing happens. Let's see what's wrong. So I have the mesh, the solver. Let's see. Oh, it's nothing's happening. Okay. So I have the solver, I have inputted the mesh, and I have the mesh here. created the attributes, relaxed. Okay, maybe if I did this, wait a minute, it says 0.001. Okay. Since I just copied the parameter from here, but it was within this directly, and I just cut and pasted inside the solver, which changed the relative path. So I have to copy this parameter again to make it link again. So let's go here and do the paste relative references again. So you see that there's a difference between the passes. So I have to follow these passes. So if I just copy this pass here, and it should get the value that I need. And this also should have something like this. Relax, not using it. Here I do use it. Yeah, this should be fine. Let's look again. Yeah. Now you can see already that it's expanding frame by frame, slowly expanding the length of the edges. Now the difference between the one we saw, with the one I just did in Houdini and the one that shows in nervous system is that they are defining which areas to be expanded. But right now I'm just expanding all the edges for the meshes. So in order to say that which areas to expand or not, I have to set attributes for each point that has to be length up. That has to be expanded. But for this one, I'm just gonna say all the edges for the mesh will be expanded, which will be much easier. So I just go with that for this tutorial. But in the future, if you want to make it looking same as the one that nervous system did, you can just add an attributes which area can be relaxed for this one. You can set which points to be relaxed here. And maybe control the scale as well here, gradually. But I'll leave that for this time. Now I already have the base remeshing function. I see that the edge length is a bit too uniform. Maybe what I can do here, that frame by frame the fit edge length will be smaller and smaller, so that it'll be faster and faster when they grow the coral. Right now it's a bit too slow, I guess. So I'll in order to do that, I can set here the last part of the solver, the remesh, And there is a target edge length, and I can set this to be smaller and smaller when the frame goes farther and farther. Now, now I already have the fit lengths that I got from the controller parameter. And what I want to do, what I can do is subtract this by number that comes from frame, but frame itself is too big, so I can multiply something like 0.002, and also I can divide this, but divide it by a parameter we made for slowing down that is used in here, the slow factor. So I'll just copy this and paste it here, and I have to remove F for this since it's an expression. Now let's see how it goes this time. Now I can see that each frame slightly the edge becomes smaller and smaller. The target edge becomes smaller and smaller, and for each frame the the speed of growing is being increased significantly. So when it gets to like 140 or 150, it's already looks like the one we want. And looks pretty good. So this is the base that's making the coral, and this is almost done. What I just want to do from here is that right now it's just a mesh plane and it's a bit blocky, as you can see. So, and as a final touch, I want to make it as a 3D printable mesh which had a thickness and continuous like mesh. So let's do that. First, as you can see, the edge right now, edge of this mesh, it's a bit pointy, blocky. So I wanna set the smooth for this mesh. And there is a smooth function in Houdini, but it doesn't seem to work pretty much well for edges, the naked edges for mesh. So I'm gonna apply some custom smooth function made in Point Wrangle. And specifically, I want to implement a smooth function called Laplacian smooth. Let's call it Laplacian smooth. Now, first you need to have a number of neighbors using neighbor count for each point. And let's set the weight of the smoothness, and could be like 1.0 divided by the number of neighbors. And let's set a variable called average vector to 0, 0, 0 and go for each iterate through each neighbors using for loop. Let's use for each. Neighbors. And increased average vector weight times the neighbor point minus the original point position. Now this vector will gonna be the direction where point should move to make it relaxed. And finally, I set a scale value, like how much it should move to scale. Let's say 0.33 as a value, and finally move the point by scale times average vector. And I can see that obviously the edge become less blocky. From here to here. Yeah, so if I increase the scale like from 0.33 to 0.5, it will be much more smoothed out. But for now, 0.33 is okay. So I'll go with this. And now, next, I want to have it like a thickness, since this is just a plain surface, plain mesh. Doesn't have a thickness, which means you cannot, if you want to make it as a 3D object physically, you cannot 3D print this. So in order to 3D print this, you have to have a thickness. There must be several ways to achieve that. One easy way could be to use the poly extrude, but I don't think this is gonna work for this complex mesh. Let's try that first. Poly extrude. And set the distance to like 0.1. Oh, it's already have. Yeah, it does seem to give a result. So this might also be okay, but some of the places have like self-intersection like these. So it still is hard to make it as a 3D object. I mean, 3D printable object like these here have some problem with a self-intersection. And most of all, the edge is like really flat. It's not really beautiful. It's too blocky. So forget about this method, and I'm gonna try using the VDB SDF method, so that I use voxel to mesh out, thicken out this. Now, in order to first convert this into voxel information, I need to convert this. I need more points in each for this mesh. Like right now, the lengths between points are a bit too far to make voxels. I have to make it more high res to be a 3D mesh, to be a voxel space. So I add another remesh here. And set the target edge length to be 0.01, which will give a really high res remesh. Now the problem you see now is that even if it did make it high poly, you see that the surface, the curvature of the surface, a bit too blocky. It's not really smooth. So after you remesh this, you want to make it smoother again. Now, in order to do that, I can again use this Laplacian smooth, and maybe one iterations for Laplacian is not enough. As you can see, it still looks blocky, so I want to continuously apply this Laplacian smooth over and over again to this mesh. So for that, I can use the for loop and let's say set the count iterations to 10 times. If I do that, now it looks much smoother. And it already looks like the one we saw in the Google image, the shape of the hyperbolic coral, and it looks pretty good. Yeah. Now this is pretty good. So next, let's convert this into VDB. First, let's feed this to a null, name this base, and call a node called VDB from particle, which converts the points, each points, to be VDB points. VDB I feed. And I have to set the resolution to be really small, I think. Right now it's 0.1, but let's say it's 0.0075 or something. And here comes looking like a brain, but the radius is too big right now, so let's set the point radius scale to be around 0.3. And now you have this coral with a thickness. It looks really good. Now, as a final touch, let's smooth out this voxel using VDB smooth. And I guess one iterations is fine. Looks really smoothed out and pretty nice. And finally, let's convert it into polygon so that you can print it out or export it out. And VDB convert VDB into polygon. Yep. Yeah, it looks really good. If I hide the edges, yes. And as a final touch, let's color this a bit. Maybe since it's a coral, purple might be okay, might be good. Yeah, magenta. Yeah. So this is about it. And you can make an animation like from the really small disk to this final growth coral. Let's make a simple animation and finish this. I'll give a cache and maybe from frame 1 to 130 is fine, or let's make it 140. And here, let's play this. Slowly, at first it's really grows slowly, but time goes by, the growth rate increases because the edge lengths got really small and small and small using the frame value, which makes it more, which takes more compute time to calculate the result as well. Obviously. And right now I'm using every edges to be calculated, so it obviously has tons of calculations. So in the end, it might be better just to filter only the edge of the mesh to be calculated. But for now, it's okay. It looks pretty, the image looks really good. Now it's almost done. Yep. And I can also control the resolution or thickness of the mesh, like in here, convert VDV or VDV from particle. Now the caching has ended, so let's feed this to the final and let's make simple flipbook. Yep. Now it's done. And this is the rendered coral growth. And it was pretty easy to make this thing. Yeah, looks good.